Good day, students. Continue our lessons. The topic of our lesson is the integral distributive function, its properties and graph. Now, first, write the integral distributive function. The integral distributive function. Distributive function. Its formula has the following form. F capital of x is integral from minus infinity to x f little of x dx. Here f little of x is distributive density, and f capital of x is the integral distributive function. Integral distributive function. Now consider the properties of the integral distributive function. Properties. First property. The integral distributive function is the increasing function. You know that if the derivative of some function is positive, it means the function itself is increasing function. Find the derivative of this function, f capital prime of x equals integral from minus infinity to x f little of x dx prime with respect to x. It is known from the calculus if this integral is definite integral, if the upper limit of definite integral is a variable quantity, then derivative of this integral is equal to the integrand at this upper limit. That is, it is f capital of x. F little of x. And here we obtain another formula. F prime of x equals f little of x. Uses that the upper integral limit is variable quantity. And also it is known that the distributive density is always positive function, f of x, f little of x is positive, then f capital prime of x also is positive, and it means that derivative of function f capital of x is positive, and it means the f of x is increasing function. That is, f of x increases. Now go to the second property and consider the behavior of the integral distributive function at minus infinity and then at plus infinity. First, consider the behavior of the integral distributive function at minus infinity. For this, we must find the following limit. Limit when x tends to minus infinity f capital of x. F capital of x. Substitute expression of f capital of x. Limit when x tends to minus infinity. Integral from minus infinity to x f of x dx equals substitute minus infinity instead of x at the upper limit into the upper limit, integral from minus infinity to minus infinity f of x dx. And you must know that if the limits of integral are equal, then such an integral is zero, is equal to zero. It means limit f of x when x tends to minus infinity is zero. It is second result, second property. And finally, consider the behavior of the integral distributive function at plus infinity. For this, find the following limit. Limit f capital of x when x tends to plus infinity equals, substitute the expression of f capital of x, limit when x tends to plus infinity, integral from minus infinity to x f little of x dx equals. Then substitute plus infinity instead of x at the upper limit, into the upper limit. Integral from minus infinity to plus infinity f of x dx, and we obtained the main probability equality, and this equality is equal to unit. It means limit f capital of x when x tends to plus infinity is equal to 1. It is the last property of the integral distributive function. Finally, construct the graph of the integral distributive function. Yx. Y equals f capital of x. It is the graph of the integral distributive function. According to the first property, this function is increasing one. You see that this function increases. Then at minus infinity, the graph tends to 0, and at plus infinity, this graph tends to unit, tends to unit. And the upper straight line is the horizontal asymptote whose equation is y equals 1, and the lower straight line it is x-axis, and it is also the other horizontal asymptote whose equation is y is equal to 0. Now consider the following example. Find the integral distributive function for the given distributive density. F of x is 2x plus 9/4 in the interval minus 3, 1, and f of x is equal to 0 outside this interval. Here the function f of x is given, and we must find the f capital of x, the expression for f capital of x. First write the condition of the function f little of x. According to the condition, f of x is equal to 2x plus 9/4 if x belongs to the interval minus 3, 1, and it is 0 outside this interval if x doesn't belong to interval minus 3, 1. And also we can rewrite this expression and separate whole infinite interval from minus to plus infinity in three intervals. Before minus 3, between minus 3, 1, and after 1. F of x equals 0 if x is less than minus 3, equals 2x plus 9/4 if x is situated between minus 3 and 1, minus 3 is less than or equal to x is less than or equal to 1. And again 0 if x is greater than unit. Already we have three intervals. Before minus 3, between minus 3 and 1, and after 3. First, verify the main probability equality for the given function f of x. Write the integral from minus infinity to plus infinity f little of x dx. This integral must be equal to unit, and prove this fact. Separate the whole infinite interval from minus infinity to plus infinity in three intervals. Before from minus infinity to minus 3, from minus 3 to 1, and from 1 to plus infinity. Integral from minus infinity to minus 3 f of x dx plus integral from minus 3 to 1 f of x dx plus integral from 1 to plus infinity f of x dx equals according to this condition, this integral is 0 because here x changed from minus infinity to minus 3 before minus 3. Therefore, this here f little of x, the integrand is 0, and in the last integral f of x also is 0 according to this condition. After minus 1, here f of x is 0. But in the middle middle integral, f of x is 2x plus 9/4, where x changed from -3 to 1. It is 2x plus 9/4. Then we have and definite integral of 0 is equal to also 0. 0 plus integral from -3 to 1, 2x plus 9/4 dx plus 0. Then calculate this integral. For this, must find the antiderivative of the integrand. Antiderivative of this integrand is x squared plus 9/4 x. And you must write the double substitution from -3 to 1. First, must substitute 1 instead of x, then subtract the expression where we must substitute -3, -3 instead of x in this expression, equals 1 squared plus 9/4 multiplied by 1 minus -3 squared plus 9/4 multiplied by -3 equals, it is unit plus 9/4 minus, it is 9, it is minus 27/4, and minus is gives plus 27/4. Here collect the similar terms. 1 minus 9 is -8, and plus 9/4 plus 27/4 is 64, and it is 9, and is equal to unit. Already we verified the main probability equality. Continue our lesson. Then consider the obtained three intervals according to this condition. Minus infinity, -3, 1 plus infinity. We have three intervals, and then obtain the expression for f capital of x in each interval. Just first interval, second interval, and third interval. And remember the expression for the integral distributive function. We must find this function, f capital of x equals integral from -infinity to x, f of x dx. We will use this formula. We will apply this formula. Then consider the expression of f capital of x in each interval, and begin from since the first interval. In the first interval x is less than -3, and f of x -3. Rewrite intervals from -infinity to +infinity, minus 3, 1, and here x. Which is first interval, second interval, and third interval. First interval, second interval, and third interval. But here integration is made until x, because f of x is a integral from minus infinity to x, f of x dx. That is, integration is conducted in this interval. And this interval belongs to the first integral, and in this interval f of x is 0 according to the condition, and therefore f of x here is 0. That is, in the first case f of x is 0 if x is less than 3. Then consider the f of x in the second interval. For second interval, x is situated between minus 3 and 1. Minus 3 is less than or equal to x is less than or equal to 1. Again, draw these intervals. Here x is situated between minus 3 and 1. Minus 3, 1, plus infinity, minus infinity. First interval, second interval, third interval. First interval, second interval, third interval. And x is situated between minus 3 and 1, according to this condition. And remember that the function f of x is integrated from minus infinity to x, f of x dx. From minus infinity to x, only to x, minus infinity to x. And therefore, already we have two intervals, from minus infinity to minus 3 and from minus 3 to x, equals, this integral is separated in two integrals, from minus infinity to minus 3, f of x dx, and plus integral from minus 3 to x, f of x dx. The first integral is defined in the first interval, and in the first interval f of x is 0 according to condition, but in interval from minus 3 to x belongs to the second interval, and in the second interval our function is 2x plus 9/4. Then rewrite this integral is 0 plus integral from minus 3 to x, 2x plus 9/4 dx. Then remember that the antiderivative of this expression, of this integrand, is x squared plus 9/4 x, and write the double substitution from minus 3 to x equals, then continue. Continue. First, substitute x instead of x. X squared plus 9/4 x minus, then substitute minus 3 instead of x. Minus 3 squared plus 9/4 multiplied by minus 3 equals, then open brackets, x squared plus 9/4 x minus, it is 9, and it is minus 27/4 and minus, then we'll obtain plus 27/4 equals x squared plus 9/4 x and minus 9/4. Therefore, we obtain that in the second interval, for which x is situated between minus 3 and 1, f capital of x must will be equal to the x squared plus 9/4 x minus 9/4. It is the second result, the expression of integral distributive function in the second interval. Then consider next interval, last interval, third interval. Finally, find the expression for f capital of x in the third last interval from unit to plus infinity. Third interval. For this interval, x is greater than unit. Then draw two intervals from minus infinity to plus infinity. Minus 3, 1, and x. Here, x is situated after unit, because x is greater than 1 unit. First interval, second interval, and third interval. Third interval, second interval, first interval. Again, remember the expression for f capital of x. F capital of x is integral from minus infinity to x, f little of x dx. Here, in integration is made from minus infinity to x, from minus infinity to x. Already, our interval from minus infinity to x is separated into three intervals: from minus infinity to minus 3 to 1, and from 1 to x. Therefore, we can write three integrals: from minus infinity to minus 3 f of x dx, plus from minus 3 to 1 f of x dx, and plus from 1 to x f of x dx equals. In the first interval is the interval of the first integral is the first interval. In the interval from minus to minus 3, f of x is 0 to 0. Second second interval is the interval of the second integral coincide with the second interval, and this interval f of x is 2x plus 9/4. And the interval from 1 to x belongs to the third interval, and in the third interval f of x is 0, according to the condition. And definite integrals of zeros again are zeros, equals 0 plus integral from minus 3 to 1 to x plus 9/4 dx plus 0 equals. Then find the antiderivative. Antiderivative is x squared plus 9/4 x with the double substitution from -3 to 1. -3 to 1. And already we know that according to the main probability equality, it is unit, and we can show this result. First, substitute unit instead of x, subtract, then substitute -3 instead of x. 1 squared plus 9 fourths multiplied by 1 minus -3 squared plus 9 fourths multiplied by -3 equals 1 plus 9 fourths minus, it is 9, minus 27 fourths equals, then open brackets, 1 plus 9 fourths minus 9 plus 27 fourths equals, then collect the similar terms, 1 minus 9 is minus 8, but 9 fourths plus 27 fourths is 36 fourths, or is equal to 9, and we will obtain 1. That is f of x, f capital of x is 1. Is 1 in the third interval. Finally, we can write answer. F capital of x equals 0 for x is less than -3, equals x squared plus 9 fourths x minus 9 fourths for x situated between -3 and 1. And it is unit, it is 1 for x is greater than 1. It is answer. Now please rewrite your homework. Find the integral distributive function for the given distributive density. F of x is 3x plus 11 seconds in the interval -2, -1, and f of x is 0 outside this interval. Please rewrite your homework, your assignment, and then continues our lesson. Now go to the uniform density. The uniform density. The uniform density is defined by the following formula. F of x is C. Here C is some constant value. C. If x belongs to the interval a, b, and f of x is 0 if x doesn't belong to this interval a, b. It is the definition of the uniform density. Uniform density in Azeri it is muntazam, and in Russian it is равномерный. Равномерная плотность. Muntazam sıklık. We can here C is constant value. C is constant value. We can define the value of constant C using the main probability equality. Remember this equality, integral from minus infinity to plus infinity f of x dx is 0. I'm sorry, is unit. It is the main probability equality, or the main probability identity. You can rewrite this condition using intervals. Using intervals. F of x equals 0 until a. If x is less than a, is c if x is situated between a and b, and again it is 0 if x is situated after b. And here we will obtain three intervals: before a, between a and b, and after b. And use this the main probability equality. Integral from minus infinity to plus infinity f of x dx is unit. Then separate this integral in three integrals. Integral from minus infinity to a f of x dx plus integral from a to b f of x dx, and plus integral from b to plus infinity f of x dx is unit. Continue. Before a, f lit of x is 0, and after b also f of x is 0. But between a and b, it is f of x is c. We write. And the definite integral of 0 is also 0. 0 plus integral from a to b, c multiplied by dx plus 0 is unit. Then continue. Here c is a constant value, and we can take it out of the integral symbol. C multiplied by integral from a to b dx is unit. Continue. Here integrand is unit, and you know that the antiderivative of unit is simply x. C multiplied by x with the double substitution from a to b is unit, and it is c multiplied by b minus a. At first substitute b instead of x, minus then substitute a instead of x. B minus a is unit, equals c is 1 over b minus a. Here b minus a is the length of the interval AB. And therefore we can rewrite the uniform density f of x equals 0 for x is less than a, equals 1 over b minus a for x between a and b, and again 0 for x is greater than b. It is the final expression of the uniform density. Thank you very much.